In this video, we're going to talk about operations with polynomials. The operations we'll concentrate on are with addition, subtraction, multiplication, and division. When we add polynomials, we are simply combining like terms and writing in descending order. When we subtract polynomials, we need to be sure to distribute the negative to all terms in the quantity that we are subtracting. Then we combine like terms and again write in descending order. For multiplication, we have a few different techniques that we'll be talking about today. The basic rules are to multiply coefficients by other coefficients and apply any exponent rules that need be. Most likely that's the product rule. We can distribute, and some of you know that as the FOIL technique, but remember FOIL is only used for binomials. So if we have other types of polynomials like trinomials or multiple term polynomials, then distributing is the way to go. Finally, we'll work with dividing by a monomial term, so I'll show you the separate and simplify technique. To add or subtract polynomials, make sure you're checking what the sign is. So I've got a quantity added to another quantity. So with this plus sign, a positive 1 is actually being distributed to every term in the quantity. And we know that multiplying by positive 1 does not change the sign of the terms. So basically, we are just removing the parentheses. So our first term is negative 7x plus 5 minus 3x squared plus 7x plus 5. So scanning, I'm looking for like terms to combine. I see that negative 3x squared is the only term with x squared. So I start with that highest degree term. Remember, degree is just another name for the exponent. Next, I'll look for my first degree terms. I've got a negative 7x and a positive 7x. Well, negative 7 added to 7 is 0, so I don't have any first degree term remaining. That leaves positive 5 plus 5, that would make plus 10. And there we have added our polynomials. Notice the final answer is written from the highest powered term to the lowest. In example 2, we have subtraction. So the negative is actually multiplied by each term in the quantity. So 2x squared plus 5. Negative times 3x squared means we're subtracting 3x squared. And negative times negative 9 turns into addition of 9. So I have some like terms with my x squared terms. 2 minus 3. Those are the coefficients that are getting combined to make a negative x squared. Then I have 5 plus 9. That would be adding 14. So we have our simplified term, negative x squared plus 14. Here we just have another format for showing subtraction. I've lined up the terms vertically instead of side by side horizontally. Since it is subtraction, we will distribute the negative to each term in the quantity, and what happens is the sign of every term will change to its opposite. So it becomes plus negative 3x to the fifth, negative 6x squared, plus x plus 8x, and minus 2. So my fifth degree terms, 5 minus 3 would make 2x to the power of 5. Negative 4 and negative 6 make minus 10x squared. Positive 3 and positive 8 make positive 11x. And finally, negative 7 and negative 2 make minus 9. So remember that when you are subtracting a polynomial, that negative needs to be distributed to every term in that polynomial. Then you're combining your like terms. One application problem that could be done with addition of polynomials is the perimeter of some shape. Now this shape is four-sided So I'm just going to pick one place to start with x squared, and I simply add all of the other sides to that amount. So I'll just continue in a clockwise direction. So I'm adding that quantity of negative x plus 3. Then I'm adding 9x. And finally, I'm adding this trinomial. And that's x squared minus 2x plus 4. So if I have a plus sign outside of the quantity, I'm distributing positive 1 that does not change the sign of anything. So I can simply remove the parenthesis. X squared minus x plus 3 plus 9x remains the same. Again, I have a plus outside of the quantity, so the signs will not change. So I'm just looking for like terms to combine, starting with the highest powered terms. That would be my x squared terms. So 1x squared plus 1x squared makes 2x squared. Then my first degree terms, negative x plus 9x minus 2x. So there's 3 that I'm combining. Negative 1 and 9 make 8. 8 take away 2 would make positive 6x. And finally, 3 plus 4 make positive 7. So you can see 2x squared plus 6x plus 7 is written from the highest to the lowest power. And since they give us the units in centimeters, this whole answer would be in the units of centimeters for the perimeter.